we'll do the gate previous year question from chemical kinetics topic. Okay, I completed the jam previous year questions of this topic. So now I decided to cover from 2011 to 2021 previous year gate question of this chemical kinetics. Okay, so this I'll cover this whole topic in two videos. So first video will cover from 2016 to 2021, and the next one will be of 2011 to 2015. Okay, so chemical kinetics, you as you know that this is a very important topic for physical chemistry as a gate perspective, but it's also very important as a jam or net also. So so we can see max 2 3 question in every year, each year. So that's the reason, so it's very important topic. Okay, so let's start from 2021. Okay, so our first question is the rate constant for the decomposition of a molecule in the presence of oxygen are this one at 0 degree Celsius, and this one 2.6 10 to the minus 4 liter mole inverse second inverse at 25 degrees Celsius, and it's given that R value, and the asks the activation energy of for the reaction. So this is very easy question. So it just asks one decimal place. Okay, so what's the equation we know, and the RNAS equation from RNAS we know that K is equal to A e to the power minus EA by RT. So from this equation we can derive uh, log K2 by Q1 is equal to EA, that is activation energy, 2.303 into R T2 minus T1 by T1 into T2. Okay, so this is very important equation. We can see many questions and each from this equation, so just it's better to remind this equation in exam. Okay, so our K2 here, so log of K2 2.64 into 10 to the power minus 4 by K1 is 0.237 into 10 to the power minus 4 is equal to EA by 2.303 into 8.314 T2 is for 25 degrees Celsius, so that will be 98 minus 273 because it is 0 degrees Celsius, so by 298 into 273. So when you calculate this one, the EA will be, the activation energy will be 65.2 kilojoule per mole. Okay, so our next question, so it came in 2020. Okay, so that question is, the in a reaction X is converted to product Y and Z consecutively, means parallel reaction, X to Y and X to Z. Okay, so with rate constant, this one and this one, so this one rate constant is 6.0 into 10 to the power minus 2, and the second one is 9.0 into 10 to the power minus 3. Okay, okay, so now they asked if the initial amount of X is 12.5 moles. Okay, this one initial was 12.5 mole initial. Okay, so the number of moles in of Y formed in 10 minutes. Okay, and they asked for one decimal place. Okay, so our equation will be, what is our equation for parallel reaction? For parallel reaction we know that and this one K1 and this will be K2. Okay, so the concentration, or in here it is mole number, so the answer will also be mole, that will be Y. Here they asked about Y, so it will be K1. A0 means the initial concentration of X. Okay, A0 by K1 plus K2, 1 minus e to the power minus K1 plus K2 into T. Okay, so K1 here is 6 into 10 to the power minus 2. A0 is 12.5 mole. Okay, you can also write the equation units of this one. This one unit is, the unit is, what is the unit is, minute inverse. Okay, minute inverse. So here 6 into 10 to the power minus 2 plus 9 into 10 to the power minus 3, that also in minute inverse. Okay, so 1 minus e to the power minus K1 plus K2. Here also K1 plus K2 is, so we can write, or we can also simplify this one, like 6 into 10 to the power minus 2 means 60 into 10 to the power minus 3. So if we sum this one, means add this one, K1 plus K2, so it will be K1 plus K2 will be 60 plus, here it is 9, so it is 69 into 10 to the power minus 3, and it is K1 plus K2 into T. So K1 plus K2 into T will be 69 into 10 to the power minus 3 into T is 10 minutes. Okay, 10, so it will be 69 into 10 to the power minus 2, that is 0.69. This is a simplification. Okay, so it will be 0.69. so minute inverse cancel out, and only mole is there, so it will be, so that is 6 into 10 to the minus 2 into 12.5 mole by 69 into 10 to the power minus 3 into 1 minus e to the power minus 0.69. Okay, so if you calculate this one, it will be approximately 5.41 mole. This is our answer. So what is important for this question, that is this equation. If you remember this equation, this is important, so it will be easy for you to do the question, because you have to remember this one, because the derivation is quite large one, so in exam it will be helpful for if you remember this one. Okay, so our next question, so it came in 2020, that is the fluorescence quantum yield, and given is fluorescence quantum yield and the fluorescence lifetime of a molecule is at q is quantum yield of is 0.4. okay, and 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 the fluorescence lifetime, and lifetime is given, lifetime TF, because is fluorescence. Okay, TF is also given, that is 5 into 10 to the power minus 9 second, and it's given that if the fluorescence decay constant, decay rate constant is given this one, so what is the value of Y? So we know that decay rate constant rate constant into lifetime is equal to quantum yield. Okay, so y into 10 to the power 7 into 5 into 10 to the power minus 9, that will be 0.4. okay, it's simple, because then y will be 10 to the power minus 2 into 5, that is, okay, it is 100 into 0.4 by 5, 20, so this will be 8. This is our answer. You just have to know this equation. Decay rate constant into lifetime is equal to quantum yield. Okay, very easy. So our next question that came in GATE 20. So it asks the enzyme catalyst reaction. Okay, for a enzyme catalyst reaction, the plot of inverse of initial rate against inverse of initial substrate concentration is linear with slope 0. Slope is given as 0.16. okay, and intercept of 2 point is 2.12. okay, so the estimated value of Michaelis constant. okay, what is they asked about Michaelis constant, and it is they asked for 2 decimal place. okay, so we know that a rate constant means our rate. What is the rate of this enzyme catalyst reaction? So if we derive this equation from E plus, means you just, what is the derivation? The rate will be, rate is K2 E S by Michaelis constant Km plus S. okay, so what is K2, what is Km? okay, so if the equation is E plus S to K1, it is K inverse ES to K2 P plus E, this one. So this is K2 from ES, this is intermediate on ES, and the P is product, IE is the enzyme. So E and S is the substrate. okay, these are, if we derive this from this equation, so our rate will be this one, where they asked about the plot of inverse of initial rate. So 1 by R is equal to Km by K2 E S plus 1 by K2 E. K2E is the concentration of enzyme. okay, so they asked for the slow graph is 1 by R versus 1 by S. okay, so if this is, we can tell the Y, and this one is X, so this part will be M and this part will be C. C is intercept. Say, so intercept is 2.12. okay, so 1 by K2 E is 2.12, that is mole inverse liter second. okay, and they asked for the Km. So M or slope is given, that is 0.16. so Km K2 E is equal to 0.16, that is in second. So km 1 by k2e is equal to 8. So km will be 0.16. Okay, just so k2 1 by k2a is equal to 2.12. So km into, so this will be 1 by 2.12, because this whole one is 2.12. So this will come downside. So this is second. So this one will be mole inverse liter second. So second cancel out. So these are in 0.07 mole liter inverse. So this is our answer. Okay. So our next question, so that is came in 2019. So in 2020 there is 3 questions from chemical kinetics. So in this question is from activated complex theory. Okay, the concept is activated complex theory. So for a bimolecular gas phase reaction, P plus Q is Q to R. The given reaction is P plus Q to R. Okay, the pre-exponential factor is 1 into 10 to the power 13 dmq mole inverse second inverse. Okay, the standard entropy of the activation at 25 degrees Celsius. Okay, they asked for the standard entropy of the activation. Okay, so okay, so what is given? The standard concentration C0 is given, Planck constant is given, and Boltzmann constant is given, and the gas constant is given. Okay, so what is the equation, or what is the activated complex theory of is given? So the equation will be A means in Arrhenius equation, from Arrhenius equation. So the sorry, the spelling is okay. This Arrhenius equation, K is equal to P e to the power minus Ea by RT. Okay, so this A is pre-exponential factor. So, and from activated complex theory, so this will be know that A will be this pre-exponential factor. A will be from activated complex theory. Okay, complex theory. So A will be e to the power del S activation by R into K T by H, that is K is Boltzmann constant, into e to the power 1 minus del N G. Del N G, and there is another term, that is C0, not here, 0 is not here, so C0 1 minus M del Ng is equal to 1 minus m. M is molecularity. Okay, molecularity. Here it is bimolecular, so m is 2. So this equation show this equation is for order greater than 1. Okay, for unimolecular reaction. Okay, for unimolecular reaction, this C term can be it's not there. Okay, means the equation will be there: a e to the power del S activation or kt by h e to the power minus 1 minus ng. So this term will be vanished for unimolecular reaction. So this is important. Okay, for greater than 1 molecularity means, sorry, this is not order, this is molecularity. Okay, this is molecularity. So if now when the order when the molecularity is greater than 1, the equation will be this one. For unimolecular, this one. Okay, so here it is bimolecular, so this equation will be our main equation. So a is given, that is 10 to the power 3 dm cube mole inverse second inverse. So we will write everything with unit, because unit is very important here. Okay, 10 to the power 13 dm cube mole inverse second inverse. Okay, e to the power del S by r is 8.314. okay, into kt, that is e to the power. Okay, not e into to the power, and this term is different, separate from exponential. So k 1 into 38 1.38 into 10 to the power minus 23 joule per Kelvin into 298 Kelvin. Okay, by 6.62 into 10 to the power 34 joule second. So and into e to the power 1 minus del ng. Okay, ng is 1 minus m, so ng is 1 minus m. M is 2, means minus 1. Okay, 1 minus 1. Okay, into C0 1 minus m, 1 minus 2. So here joule cancel out and Kelvin cancel out. C0 to the power minus 1. Okay, what is the C0? That is unit is mole dm cube minus, so 10 to the power 13 if you calculate this one, 1.38 into 10 to the power, So this will be 6.23 into 10 to the power 12, here second inverse. Okay, here it is second inverse, and this one will be e to the power 2, and this one c0 is 1 in 1, so 1 to 1 mole inverse dm cube. So you can see that second inverse cancel out, mole inverse cancel out, dm cube cancel out, everything is cancel out. So now is e square. Okay, now just take ln to each side. So if we take ln here, so it will be delta s. So now this term will come here, so 10 to the power 13 into 8.314 by 6.23. okay, just a minute, if I did wrong here, I think. So sorry, 8.314 not will be there because it is ln here and here r, I'm writing it as r. Okay, 8.314. okay, so that is 10 to the power 12 into e square. If you calculate this one, this will be minus 12.66, and the unit is of r, the r unit is this one, that is joule per Kelvin mole inverse. Okay, so this is our answer. So important equation is this one, very important equation. Okay, this one you have to remember this one, and you have to remember, you have to understand the derivation also. This is also important theory of your chemical kinetics topic. Okay, so our next question is 2000 from 2019. okay, just a minute. So what is the question? In friend-Lewis isotherm, a linear relationship is obtained. Which graph? Okay, so first you have to know the what is friend-Lewis equation. Friend-Lewis equation is x by m k p to the power 1 minus n. Okay, these are friend-Lewis equations, where x is the mass of the gas, that is adsorbed, mass of the gas that is adsorbed, and m is mass of the adsorbent, means in which surface the gas is adsorbed. Okay, okay, adsorbent means the upper means the molecule, means this one, the gas which is adsorbed, that is called adsorbate, and the in which surface it is adsorbed, that is called adsorbent. Okay, adsorbent. So x by m is the surface coverage, means x by m is theta here. So we can write as a theta is equal to k p to the power 1 by n. So this cannot be the linear because theta is k p to the power 1 minus n 1 by n. So it's not a linear equation. ln theta versus p. ln theta is equal to ln k plus 1 by n ln p. So ln theta versus p cannot be the linear one. Theta versus ln p. So this also cannot be the linear. So what is the linear? That is ln theta versus ln p. Y is equal to c plus mx. M is the slope, that is 1 by n. X is ln p. That will be the linear one. Okay. This is 1 by n, that is the slope, and the intercept is ln k, it is c. Okay, our answer will be B. So our next question from 2019. So this question is also this type of, okay, this type of same the parallel legs. This also the question of parallel legs. Just a minute. Okay, here from P to Q, Q1, and from R, that is K2, rate constants. Okay, P to R. So K1 K2 is given, and initial concentration is given, and R, they asked for R at for 10 minutes. So same equation, you just time also is given as same, just do that. And here it's y, that is K1, that equation will be K2 only. In the place of K1, that will be K2, because they asked for the R is corresponding rate constant is K2. So the equation will be R rate constant, that is K2 by K1 plus K2 A0, the initial concentration of P, 1 minus e to the power minus K1 plus K2 T equation, and giving the answer, that will be just 2.59 mole per liter. This is our answer. You do it yourself. Okay, this is easy. So our next question that came in 2018. Just a minute. So what is the question? That is the radioactive isotope, means when the any radioactivity activity is there, so the reaction will be first order. Okay, anything, any radioactive equation. So this substance, the time required for 50% disintegration is 8 days. The time required for 99.9%. So this is very easy. First we have to calculate K, rate constant, from T half, that is 0.693 by T half. T half is 0.693 by 8. So K is, we got the K. So now the equation, T is 1 by K, T is time, K by 1 by K ln A by A minus X. means completion of 99.9%, means a minus x is the remaining one, means what is remaining? 1 minus 0.999, that is 0.001. So okay, it is 1 by 8, 0.693, okay, sorry, 8 by 0.693 ln a by a0, sorry, it is a 0.001 a. So T will be 79.7 days. These are answer if you calculate it yourself. Okay, so our next question for 2018. So that is the low partial pressure of ozone O3, and the adsorption of ozone on graphite surface is fully dissociative in nature. You just careful about the term dissociative. Okay, follows Langmuir isotherm. Okay, so under this condition, if the dependence of surface coverage of graphite theta on partial pressure ozone PO3 is theta PO3 x, the value of x. What is the value of x? So you know that theta for dissociative reaction, theta will be Kp to the power 1 by n by 1 plus Kp to the power 1 by n. N, what is n? N is the number of atom in the molecule, means O3. So number of atom is 3 because 3 oxygens are there. So here n will be 3. So it's if the dependence on surface coverage is on partial pressure, okay, and low partial pressure means low partial pressure is given, okay. So here Kp to the power 1 by n will be, okay, just a minute. Here, low partial pressure is P is much less than 1, so Kp by 1 by n in this condition much less than 1, so theta will be Kp to the power 1 by n by 1, okay, because this term is very less in amount. So here they ask for the x p to the power, that is k p to the power 1 by 3. 1 by 3 means 0.33 approximately. So our answer will be 0.33. So our next question that came in GATE 2017. Okay, what is the question? The rate constant of the reaction is 1.25 10 to the minus 4 mole liter inverse second inverse, okay. If the initial concentration of the reaction is 0.250 mole liter inverse, the total time required for the complete conversion, means they asked for the complete conversion. When any question, in any question they ask for the complete conversion or complete reaction or the time taken for completeness of the reaction, so you just you can easily so you can easily consider is as a zero order reaction, because in the completeness means the reaction of order 1 is never complete. It cannot be complete in any time. So it will be zero order, and the from the unit you can also decide that this will be zero order. The general form is unit is mole liter inverse 1 minus n second inverse. N is the order, so if n is 0 then the unit is same. Okay, so here is given the rate constant. Okay, so the equation of zero order reaction is a t. T means time t. At time t the concentration of a is equal to a0 at means at 0 times 0 kt. Completed reaction means the remaining at is 0, means all the reactant converted to product, so it is 0, is a0 minus kt. So time will be a0 by k. a0 is 0.25 mole liter inverse, mole liter inverse by k. K is 1.25 into 10 to the power minus 4. So that is mole liter inverse second inverse. So mole liter inverse second inverse, mole liter inverse is cancel out only second inverse. So if we calculate this one, so that will be this 10 to the minus 4 will go upside by it is 5, so that will be 2000 second is our time required for the complete conversion of the reaction. So our answer is 2000 second. Okay, so these are next question from 2017. Okay, just a minute. So the question is dependence of rate constant k on temperature of the reaction is given by this one. This is the equation. Okay, activation energy is, what is the activation energy? So this is RNS equation. K is equal to a e to the power minus ea by RT. So ln k is ln a minus ea by RT. So this one is 10, ln k is given, so this term is will be this term, so minus ea by RT will be 5000 by t, that is minus cancel out, t cancel out, so ea will be 5000 into 8.314. okay, so that will be 4.507 joule per mole. That will be 41.6 kilojoule per mole. This will be our answer, easy. So our next question, that is from gate 16. From gate 16 there is a 4 questions came, okay, from this topic. Okay, so maximum there is 4 question is there, so in each year you can see 2-3 question, but sometimes you can get 4 or 5 questions are there, not 5 question. So my 4 questions will be, you can see. So what is the question? So for this following reaction a plus b to I and p, from here this is the equilibrium, and if the steady state approximation can be applied on I from this, okay, the observed rate constant of the product formation in this unit. So if we uh, apply the steady state approximation on di, so di dt will be k1 a into b, because I is producing from a plus b, so plus k1 a b and minus k inverse I, because I is decaying from to a plus b, so this one minus whatever is producing that will be positive and whatever is decaying that will be negative. From here it is also decay, so that will be minus k2 I. So if we apply that steady state approximation, this di dt will be 0. 0 will be k1 a b minus k inverse I. Okay, k2 I. Okay, now I will be this k1 by k inverse plus k2 a b. Okay, a into b. So what is the rate of the reaction? Rate of the reaction is this one. Rate is k2 I. So I is here, so rate will be k2 into k1 by k inverse 1 plus k2 a b. So this term is the rate constant for this reaction. So they ask for this, what is the value of this term. So they are given k2, k2 is 10 into k1, k1 is 10 to the power 5 by k1 inverse plus k2, k1 inverse is 10 to the power 4. Okay, you write the unit also here. Okay, what is the unit? K2 is second inverse, k1 is mole liter, mole inverse, second inverse. Okay, okay, we'll calculate the in last. Okay, at last. So k inverse is 10 to the power 4 second inverse, and k2 is also plus 10 second inverse. So this is second inverse, and the upper portion will be liter mole inverse percent inverse for the k1, and k2 is second inverse, so this will be 2. If we cut this one, so this will be second inverse only. Okay, we got our equation: liter mole inverse second inverse, liter mole inverse second inverse. Okay, so this will be 10 to the power 2 mole inverse liter second inverse. So this will be our answer. Easy thing, we just have to the di dt will be 0 for steady state approximation. Okay, then it will be easy. So our next question, 3 questions are remaining. That came in gate 16 from adsorption. The adsorption of CO, carbon monoxide, on charcoal at 273 Kelvin follows Langur isotherm. A plot of K by V versus P is linear with a slope of 0.01 and intercept of 0.5 and the equilibrium constant K. What is the equilibrium constant K? So just have to know the equation. What is the equation for Langmuir isotope? That will be P by V adsorption is equal to 1 by KVM plus P by Vm. This is our equation. So P by V versus P by V versus that P. This is the graph and the slope is, so this will be the slope. So slope will be Am is equal to 1 by Vm, that is 0.01. okay, intercept Y is 1 by KVM, that is 0.5. so they asked for the K, so K will be 1 by Vm into 1 by 0.5. 1 by Vm is 0.01 by 0.5, 1 by 50. So that will be 0.02. So our answer will be 0.02. okay, easy. Just have to know this, the equation for Langmuir isotope. okay, so next question. The reaction is fast order both direction, okay, from reverse direction and also forward direction. Forward and reverse rate constants are there. Relaxation time for the reaction in a temperature jump experiment. In a temperature jump experiment, the relaxation time for this equation only, when A and B, if there is A plus B to C or A plus B to C plus D, the equation will be different. But for the only this type of, where A to B is given in equilibrium is there from A to B, so in this type of reaction the relaxation time will be T is 1 by K1 plus K2. What is K1? K1 is a forward rate constant, K2 is reverse rate constant. So K1 is 4.2 into 10 to the power minus 4 plus, that is also second inverse, so 1.04 into 10 to the power minus 3, both are second inverse. So if you calculate this one, this will be 684.93 second. You just have to remember this equation. You have to remember that, you have to careful that this equation only for this type of equation where A and B is in equilibrium. But if A plus B to C in equilibrium or A plus B any other than this one C plus D, the relaxation time equation will be different. So I am not going that one for that one. So you just remember this equation only. okay, our last question of this, today's last question. okay, so that is for elementary bimolecular gas phase reaction, activation is given, enthalpy of activation they are asking, and temperature 300 Kelvin. okay, so it is activation energy and enthalpy of activation means this is the activated complex theory. okay, for activated complex theory, delta H, that is enthalpy of activation, is equal to del U. This has is for the activation only. This will signify the activation. okay, plus del n g rt. We before we did this one, that is okay, this one. Okay, here del ng, same thing, this also activated complex theory, this also activated complex theory. So del ng is 1 minus m. Okay, m is molecularity, so it is unimolecular, oh sorry, bimolecular, so that will be 1 minus 2, that is minus 1. Okay, and del u is not given here, activation energy is given, so there is another equation, that is ea, that's activation energy, that is del u plus rt. You remind these two equation, so del u activation is equal to ea minus rt. Put this one here, so del h is equal to ea minus rt plus here it is minus 1 rt. So minus here minus 1, so minus 2 rt, that will be ea minus 2 rt. So ea is given, ea is 5.5 kilojoule per mole, so 5.5 into 10 to the power 3 joule per mole minus 2 into 8.314 into 300. So if you calculate this one, the answer will be 511.6 joule per mole, or they are asking in kilojoule, so that will be 0.5 kilojoule per mole. Only one decimal you can write, so that will be 0.5. So in this, for this question you have to remember this equation for activated complex theory and this equation. These two equation is important. You can derive this equation, but it is better to remind this equation, so it's very easy. So I completed from gate 16 to gate 21 all the question from chemical kinetics. So in my next video I'll cover from 2011 to 2015. So as a whole, from 2011 to 2021 all the chemical kinetics questions will be covered, and this will be very helpful for you, because this is very important topic in all the exam perspectives. So in our next videos I'll cover the CSR net questions from this topic. Okay, so if you like the video, please subscribe my channel, and so if you want such type of videos in future, so comment in the comment box, and please tap the bell icon, and so that you can easily get my future videos. Okay, thank you, bye bye.